SwayamPrabha. Digital India. Educated India.
Welcome to today's lecture. We have just started to discuss the topics on mineral exploration. We just before we get into the proper mineral exploration topics, we just had a brief overview of classification of mineral resources based on their economic criteria and geological certainty, the occurrence of these resources, and the idea behind looking at our idea behind having this kind of classification at the back of our mind is that this when we classify the mineral resources into broadly into the identified and the undiscovered resources. So, it is essentially the undiscovered or the probability range, the hypothetical or the speculative part of the mineral resources is the one that we would like to convert it into identified through the process of mineral exploration, which is a very elaborate exercise involving lots of scientific techniques with lots of evolving ideas, with the development of technology, and with evolving ideas, with better and better knowledge on the genesis of different types of mineral deposits that have come to our knowledge, they have been constantly adding to the knowledge base on the wide spectrum of mineral resources, mineral deposits that occur in the earth's crust. Sometimes there are some new discoveries, new types of deposits which give us many new insights into the ore forming processes, and in the long run they add to the knowledge base on which we can plan our exploration efforts, we can design our exploration programs and use of different technology for the exploration, as we have already stated that it would the mineral exploration as a full range of the activities, exercise, the methodologies, technologies that is involved in this would be difficult to cover them up all in this short lecture series. And in this, when our basic objective is to get an overview of the elementary knowledge about these topics. So, we will just try to do that, and we saw the McKelvey's box where it is where the mineral deposits or the mineral resources are classified. So, measured is the one on which we have the least uncertainty in the calculated amount that is present in terms of millions or billions of tons or millions of ounces, as we saw in our early discussion. The part that is covered under indicated will basically involve a little bit more of uncertainty, and the inferred is also accordingly involve greater uncertainty in their quantity that is available. Sometimes even we come and propose we even use words such as developed. Developed part of the reserve, that part of the ore body which is developed in the sense that which is ready to be put into production in a mine by defining certain parameters such as the ratio of the quantity of the overburden that is to be removed to get the ore, to produce the ore. Sometimes the ratio sometimes would be 4:1 or even more, and the higher is the this ratio, which is called as the strip ratio. Higher is the strip ratio, higher is the cost of mining. These are the aspects that we will be discussing a little bit more details in our later section of the lecture series, when we will be discussing about the mineral resource appraisal and the estimation. Okay. We also started the discussion that reporting in the form of this reserve as measured, indicated, inferred, or possible, or proved possible, proved probable and possible. This kind of reserve reporting is not very consistent. There are chaos in terms of the terminology that is used in proved mineral resources, and there is a bit of a conflict in reporting of the mineral and the fuel resources. So, the United Nations framework that was proposed was a kind of a consistent and a uniform code of reporting the mineral resources, and which has certain advantages. And as we saw them before in the previous classification scheme, when only the two parameters, one is the geological certainty and the other the economic viability and feasibility, were combined together, and the mineral resources were classified as we saw in the McElvis box. So, this is basically the CRIR-SCO committee, that is for Committee for Mineral Resources Reserves International Reporting Standards, which was the old one that was followed. And this was the application was in mining, processing, metallurgical, economic, marketing, legal, environments, infrastructure and social and governmental factors, all factors taken together. And we discussed about the classification scheme that was adopted for the United Nations framework classification, where the three the socio-economic viability and the feasibility are now being plotted on two different axes, and the geological knowledge. And as we know that the geological knowledge G4 to G1, it is in the increasing order. G1 represents the one about which the geological certainty is the most, and it is kind of the existence of the in the form of an ore body of the required dimension is proved to be existing by using various direct and indirect methods. And the project feasibility is essentially in terms of the economic feasibility of developing that mine and going on with the mining operations, where the it could be done on a sustainably profitable manner. And the socio-economic viability, that means meeting all other socio-economic parameters, and that this is the way the mineral resources are classified. And this numbering system means 111 is actually the ones which are the commercially producing mines, the ore bodies in different as we see them today, and the ones which as we have seen before, here also in from F1 to F4, it is in the F4 to F1 in an increasing order of project feasibility, and E3 to E1 increasing order of socio-economic viability. So, the ones which are in brown here are potentially commercial projects, in the sense that the geological certainty has been proved and the project feasibility is also quite high, and the economic viability is also somewhere intermediate, and they represent the potential projects which could be converted into commercial projects as and when any of these criteria are fulfilled. This would be a thing which generally we require to know, that how this UNFC classification and the old classification scheme, they map to each other. As you can see it very clearly, what we label as probable or the proved one, which is the least certainty in their estimation in terms of the quantity that is present, and the probable, and they would actually map onto this 111 1 it will be also be 112 sorry 112, this will be 113. So, a 112 can always be also be say here the quantity is estimated, although with a little greater uncertainty, and the ones which are the inferred or the indicated will be the non-commercial one, where the geological knowledge are, say this is for example, this 2 to 3 or 2 to 2, where the geological certainties are still very less, but they could be potentially commercial, they could become potential producing ore bodies in any time in the future after the parameters are satisfied. And the situation like a 334 is where only the exploration results have been obtained, and the geological certainty is still to be proved, and although it could possibly be a little bit feasible in terms of the project feasibility and whose economic viability is not yet worked out. So, this is with this much at the back of our mind, that the resources, our basic idea is to convert all those which are unidentified or speculative or kind of the resources which constitute the resource base together along with the identified. So, our objective is to augment the mineral resources, increase the quantity of the any of the metal or the materials that is available to us, converting G4 to G1, although the feasibility and the economic viability are dictated by lot many other factors, non-scientific factors. Converting a particular mineral resource from G4 to G1 is essentially what we aim at, and go through the process of this exercise, which is mineral exploration. So, when in the context of mineral exploration, these are the basic questions that come to our mind, that what to explore. To answer to that question as what to explore, it is basically these are the factors, the macroeconomic factors, the demand, supply and the international price, that is going to be one of the key factors. If any particular metal, there is a demand for it and the supply is short, and the international price are such that importing of that particular metal or the material would be economically strenuous. So, that becomes an obvious choice, that particular metal to be, an exploration program for that particular metal has to be designed. There are certain situations as joint supply and joint demand. This comes out of the situation that suppose that we have discovered a deposit of iron, and then we need to establish a steel plant to extract the iron, but then it also needs some other resources like coal or limestone and other resources to actually setting up of a plant for extraction of that metal. So, that makes it essential to go for exploration of other materials which are essential for that particular industry or particular metal extraction plant to be set up. Technological breakthrough, there could be sometimes there are certain technological breakthrough which makes a particular metal which was otherwise not known to be that very useful in the industrial in the industry. So, that particular metal could become very important, and then there could be exploration program for that particular metal. Substitute means again, because of this also a result of technological breakthrough. There could be some strategic factor for example, energy resource mineral like say for example uranium, it definitely is on the priority list of augmentation of the mineral resources, and it would always be better if we could discover large deposits of such kind of metals, and because they have got strategic importance in terms of generation of energy and many other aggressive political factors. So, these are some of the things that come to our mind when we try to answer that what to explore. And then the next question comes to our mind in regarding mineral exploration is where to explore, means which area to choose for conducting an exploration program. So, number one is ancient workings. Ancient workings are things which are the vestiges or the remnants of mining activities which were carried out by our ancestors in the prehistoric times, when we all know about the history of use of metals like the copper age, bronze age, iron age and so on, where in the ancient time not much of technology of mining was available, and only the minerals, the mineral bodies which are only exposed to the surface, most of the time they are oxidized. So, those were the ones which were worked by the prehistoric man for extraction of different types of metals by very crude rudimentary technologies like a village blacksmith shop, where metal oxides could be melted and could be extracted, and such kind of old workings are left in many different parts in remote places, which give us indications that there are possibilities of existence of such type of ore bodies. So, they could become the areas where we could intensify our exploration efforts. Favorable geology, it is basically based on the whatever geological knowledge that we have acquired through study of this whole spectrum of mineral deposits that we have discussed so far. So, if the geology seems to be favorable for occurrence of any particular type of deposit, that also becomes an area of choice. As we have said that many times we extrapolate situations what our previous experience of discovery of deposits in different other parts of the world, although we keep a very important thing in mind that no two deposits will be same in all their characteristics, and each deposit's discovery history is also unique, as we will be seeing some of them. A political factor could also motivate choice of certain areas, and joint demand, which exactly I just discussed about joint supply and joint demand. And then the question comes as to how to explore, and that is the thing on which we will be mostly be discussing. So, how to explore is we can always think mineral exploration as having these three possible components that can come to one's mind when it comes to how to explore. The science of mineral exploration means all the principles of mineral, the scientific principles or the understanding that we have developed in the formation of the mineral deposits, that they could be effectively utilized in mineral exploration. And in addition to that, the differences or the characteristics of this kind of ore bodies when they occur in the earth's crust, their distinctiveness is also something that can be taken into account and can be a part of the science of mineral exploration. Sometimes we feel that mineral exploration, this whole exercise is since no two deposits will be alike in all respect, and no two deposit will have the same or identical exploration history, discovery history. Sometimes it becomes more of an art or practice, people who have been practicing mineral exploration for most part of their lives, they become kind of experts whose opinions sometimes matter or sometimes are taken into serious account while carrying out mineral exploration in any unknown area. And the methodology is the one also which have been continuously evolving. Many sophisticated methods for exploration of these mineral deposits have come up. So, these are the things will be the science part of it is the one which will be mostly focusing, and the methodology part it will have some limitations for this particular lecture series, but we will discuss as many as would be appropriate. In mineral exploration, we actually get to hear these two terms, that brown field or green field. A green field essentially is the areas in which the existence of any ore deposit is not known, or these areas can be called as virgin areas which have never been subjected to any exploration activity before, which of course at the present time will be very little, and the exploration would be, the process would be basically be starting from scratches, and that will be called as a green field exploration. The brown field exploration is any particular geological terrain where mineral deposits are known to be existing of any particular metal or many different, that the examples that we have seen of metallogenic provinces or the ore districts or mineral belts, where there could be occurrence of one or more than one type of deposits. For example, the Dhorwar Craton, where we see that it houses deposits from a wide spectrum of metals like chromium, manganese, gold, iron and so on. So, in such kind of areas where we already have been producing minerals from different localities, mineral deposits, we would like to continue our exploration efforts with the objective of finding many more such deposits in that particular area. So, that is because some idea about the broad geological aspects of the area is known, and we call that brown field. Sometimes we also do have this thing in our mind, that what is the difference between exploration and prospecting. Generally, these two terms are almost used interchangeably or synonymously with each other, although I would say that prospecting always would be referring to smaller areas where we are carrying out some ground activities in terms of any of the methodologies that we will be seeing, like a geological or a geophysical or geochemical, and exploration would essentially be exploring through the unknown or taking much larger area, where we can do the exploration by using not exactly a ground based work, but it could be situations which would be acquisition of data in many different other ways. This is how we could possibly make some distinction between the two, otherwise in many of the textbooks and discussions you would see that these two terms are not really very distinctly differentiated. Okay, so we will just see what this exploration is all about. Mineral exploration can be thought of as kind of a 4-stage architecture. This 4-stage architecture, it begins with, or the very beginning stage, as per the conventional conventional wisdom, that this is the situation, the exploration. Whenever we take up an exploration, mineral exploration program, then how do we start? We start with the reconnaissance stage, means we try to acquire the very basic first level knowledge in an area, and the work during the reconnaissance stage is, it involves study of a much larger area. So, generally the idea is to study a larger area with the objective of choosing smaller domains where exploration efforts could be intensified. So, this is the beginning stage. So, here if we see here, the small scale geological maps can be used. So, small scale in the geological maps, the small scale means where the scale is something like, if I say that a small scale means if I say that 1 kilometer ground distance is represented by say 2 centimeter. Here the scale is 1:50,000. In comparison to that, if I say that a ground distance of 25 meter or 20 meter is being represented by 1 centimeter, then this would be a scale which is, I could put as 1:2000. So, here this is a small scale map, and here it is a large scale map. So, we have generally a topo sheet is a scale in which we have representation of 1:50,000, and even there could be scale smaller than that, 1:100,000 or 1:63,000, as 1 inch is equal to 1 mile. That used to be the previous scale. And so, the difference between the two is that on a geological map which is prepared on a small scale, many of the features which are small or less in dimension, for example, any mineralized vein or any kind of a any structure or any smaller feature or alteration zones and so on, which will be measuring only in few tens of meters or so, will not be representable on a small scale map. Whereas, we can always or if you want to study the area more minutely and can represent many of these features, important features which is the dimensions are small, measurable in only in terms of tens of meters or so, can be well represented on a large scale map. So, here the smaller scale, the small scale geological maps are prepared as a routine geological investigation in any agency in any country, like say for example, the Geological Survey of India in India. All the countries have their geological surveys who have the primary responsibility of preparing first level geological maps, small scale geological maps, who serve as the first available information for any exploration program to begin with, and that is what is the situation which was happening in the past. Now, in the present time, if we when we see that we do also have much smaller scale features depicting the many of these surface features or the features on the surface of the earth, such as the satellite imagery. Such as these satellite imageries, which can be possibly can be thought of as the smallest possible scale that of the feature that we can have, and even we can have we can have still a little larger, but still very small, much smaller compared to toposheet scale geological map or any other map which is drawn on a toposheet scale, like for example, a regional scale airborne geophysical anomaly or airborne gravity anomaly, or say geophysical anomaly maps. So, these are the materials which can be very well utilized when we were in the reconnaissance stage and trying to identify certain features that you can pick up which would look to us as favorable to carry out further exploration work. So, we will continue discussing on this 4 stage architecture in the next class. Thank you very much.